All right, team, settle in. Today, we are tackling a subject that is absolutely fundamental to your entire career as a pilot, atmospheric pressure. I'm not kidding. If you can master this, you're not just setting yourself up to ace your exams, you're learning a core skill to be a safe, sharp pilot out there in the real world.
But let me kick things off with a question for you. What if I told you that one of the most important dials in your cockpit, the one that literally tells you how high you are, well, what if I told you it lies? Not by accident either. It's practically designed to, and it's your job to know when and why. Let's get into it.
So, here's our flight plan for this session. We're going to start with the absolute foundation. What is pressure? Then, we'll see how it changes all around us. After that, we'll spend some serious time on the instrument itself, your altimeter. We'll cover the right procedures in the air, and we'll finish with the really critical stuff, the classic mistakes that can get a pilot into a world of trouble.
Okay, first things first. Before we can even touch that altimeter, we need to understand the invisible force it's actually measuring.
So what is it? I mean, the textbook definition sounds pretty dry, right? The weight of a column of air. Okay, but here's a much better way to think about it. Imagine you're buried under a giant pile of blankets. At the very bottom, you can feel the weight of all those blankets pushing down on you. That's high pressure. But if you're near the top of the pile with only one or two blankets on you, that's low pressure. The atmosphere, this ocean of air we fly through, works exactly the same way.
Now, for your exam, you have to know this distinction. There are two kinds of pressure we talk about in aviation. First, there's dynamic pressure. That's the pressure created by your plane moving through the air. It's what your airspeed indicator uses. But what we're focused on today is static pressure. Think of it as the quiet, ambient pressure just sitting there. It's the pressure of that stack of blankets. It pushes on your aircraft equally from all sides, and it's what your altimeter needs to work.
Okay, so you get the basics. Good. Because that stack of blankets isn't nice and neat, it's a constantly shifting, changing thing. And as pilots, we have to know how to read it. And what you're seeing here is rule number 1. As you climb up, you're getting closer to the top of that stack of blankets, right? There's less air above you, so the pressure goes down. But look at that curve. It's not a straight line. That's because air is compressible. Most of the weight, most of the blankets, are squished down near the bottom, so the pressure drops really fast at first, and then more slowly the higher you go. But it's not just about how high you are. Temperature is a huge deal. Think about it. Cold air is dense, it's heavy, it sinks. Warm air is light, it expands, it rises. So I want you to imagine the levels of pressure in the air like the folds of an accordion. In cold, dense air, that accordion is squeezed shut. The pressure levels are packed tightly together. But in warm air, that accordion is stretched way out. The levels are much farther apart. So here's the key takeaway, and I promise you this will be on your exam. To reach a specific pressure level in warm air, you have to climb much higher. In cold air, you'll hit that exact same pressure level at a much lower true altitude. You have got to remember that. Okay, let's take all that theory and bring it right into the cockpit, to the star of the show, the altimeter. Because now that we know the air is constantly changing, we've got to learn how to tell our instrument how to deal with it. I need you to burn this into your brain. Your altimeter is not a ruler. It doesn't know how high it is. It's just a fancy sealed can, a barometer, that senses the static pressure outside. That's it. It just measures pressure and shows you a number in feet. We, the pilots, are the brains of the operation. We have to give that pressure reading the right context. And the most common way we do that is with something called QNH. You get this number from air traffic control. When you dial it into your altimeter, it calibrates the instrument to show your true altitude, your height above mean sea level. This is the don't hit a mountain setting. It is absolutely vital for terrain clearance.
Now, there's another one you'll encounter, QFE. This one's a little different. If you set the QFE, your altimeter will read exactly 0 when you're on the runway. It's now telling you your height above that specific airfield. It's really handy when you're flying circuits, and you just care about your pattern height relative to the runway right below you.
So what happens when we climb way up high? Well, the local pressure changes become less important for hitting mountains, but way more important for avoiding other airplanes. To solve this, everybody above a certain altitude agrees to use the exact same setting, the standard pressure, or QNE. We all set 1013.25. From this point on, we're not flying an altitude anymore. We're flying a flight level, making sure we're all reading from the same sheet of music.
And here it is, all in one place. Your cheat sheet. If you're studying for the exam, seriously, take a screenshot of this right now. QNH gives you altitude above the sea. QFE gives you height above the field, and QNE gives you a standard flight level when you're up high. Got it? Awesome.
So, knowing the settings is one thing, but when do you actually make the change in flight? Let's walk through the procedure.
This needs to become muscle memory for you. On the ground, you get the local QNH from ATC and you set it. As you're climbing out, your instrument is reading your altitude. But when you climb through a published level called the transition altitude, that's your cue. You reach over, you wind the setting to the standard 1013, and from that exact moment, you have to change your thinking. You're not at an altitude anymore. You are now flying a flight level. It's a simple action, but a critical piece of airmanship.
Okay, let's get serious. This is, without a doubt, the most important section of this lesson. Understanding the theory is great, but understanding what happens when you get it wrong, that's what keeps you alive.
So let's play out a scenario. You take off where the pressure is really high, say 1030. You're cruising along at 5,000 feet. You fly for an hour towards your destination, where the pressure has dropped to 998. But you get busy, you're distracted, and you completely forget to update your altimeter setting. Your altimeter still proudly reads 5,000 feet. The question is, are you really at 5,000 feet? The answer is a huge no, and it lies in this phrase that you need to tattoo on your brain. From high to low, look out below. When you fly from an area of high pressure into low pressure without resetting, your altimeter lies. It overreads. It tells you you're higher than you actually are. So while you're sitting there fat and happy at an indicated 5,000 feet, your true altitude is actually much, much lower, and the ground is getting closer than you think.
And here's the kicker. It's not just about pressure. Remember our accordion? The exact same dangerous error happens with temperature. If you fly from a warm block of air into a much colder one, those pressure levels get squeezed together, and your altimeter will, you guessed it, overread. This chart shows the two golden rules, flying from high pressure to low or from warm air to cold. In both cases, your altimeter reads high and your true altitude is dangerously low.
All right, let's wrap this up. Here are the absolute must-knows. 1. Your altimeter is a barometer, not a ruler. 2. Know your Q codes. QNH is for altitude above the sea. QFE is for height above a field. 3. Above the transition altitude, everybody sets standard. 4. Both pressure and temperature changes can make your altimeter lie. And finally, remember the rhymes that can save your life. High to low, look out below, and its partner, warm to cold, same story told.
You know,